We now move on to joins, which are a powerful way to bring many different tables together and combine their information. And I'm going to start us off here with a little motivating example. Now, on the left here, I see my characters table. And by now we're familiar with this table. So let's say that I wanted to know for each character how many items they are carrying in their inventory. Now you will notice that this information is not available in the characters table. However, this information is available in the inventory table. So how exactly does the inventory table works? When you are looking at a table for the first time and you want to understand how it works, the best question you can ask is the following. What does each row represent? So what does each row represent in this table? Well, if we look at the columns, we can see that for every row of this table, we have a specific character ID and an item ID, as well as a quantity and some other information as well, such as whether the item is equipped, when it was purchased, and so on. So looking at this, I realized that each row in this table represents a fact. The fact that a character has an item, right? So I know by looking at this table that character ID 2 has item 101 and character ID 3 has item 6 and so on. So clearly I can use this in order to answer my question. So how many items is Gandalf carrying? To find this out, I have to look up the ID of Gandalf, which as you can see here is 6. And then I have to go to the inventory table and in the character ID column, look for the ID of Gandalf, right? Now, unfortunately, it's not ordered, but I can look for myself here and I can see that at least this row is related to Gandalf because he has character ID 6. And I can see that Gandalf has item ID 16 in his inventory. And I'm actually seeing another one now, which is this one, which is 11. And I'm not seeing any other item at the moment. So for now, based on my imperfect visual analysis, I can say that Gandalf has 2 items in his inventory. Of course, our analysis skills are not limited to eyeballing stuff, right? We have learned that we can search a table for the information we need. So I could go here and query the inventory table in a new tab, right? And I could say, give me from the inventory table where character ID equals 6. This should give me all the information for Gandalf. And I could say, give me all the columns. And when I run this, I should see that indeed we have 2 rows here and we know that Gandalf has items 16 and 11 in his inventory. We don't know exactly what these items are, but we know that he's carrying 2 items. So that's a good start. Okay, but what if I wanted to know which items Frodo is carrying? Well, again, I can go to the characters table and look up the name Frodo, and I find out that Frodo is ID 4. So going here, I can just plug that number into my where filter, and I will find out that Frodo is carrying a single type of item, which has ID 9, although it's in a quantity of 2. And of course, I could go on and do this for every character, but it is quite impractical to change the filter every time. And what if I wanted to know how many items each character is carrying, or at least which items each character is carrying, all at once? Well, this is where joins come into play. What I really want to do in this case is to combine these 2 tables into one. and by bringing them together to create a new table which will have all of the information that I need. So let's see how to do this. Now, the first question we must answer is, what unites these two tables? What connects them? What can we use in order to combine them? And actually, we've already seen this in our example. The inventory table has a character ID field, which is actually referring to the ID of the character in the characters table. So we have two columns here, the character ID column in inventory and the ID column in characters, which actually represent the same thing, the identifier for a character. And this logical connection, the fact that these columns represent the same thing, can be used in order to combine these tables. So let me start a fresh query over here. And as usual, I will start with the from part. Now, where do I want to get my data from? I want to get my data from the characters table, just as we've been doing until now. However, the characters table is not enough for me anymore. I need to join this table on the fantasy.inventory table. So I want to join these two tables. How do I want to join these two tables? Well, we know that the inventory table has a character ID column, which is the same as the characters table's ID column. So like we said before, these two columns from the different tables, they represent the same thing. So there's a logical connection between them, and we will use it for the join. And I want to draw your attention to the notation that we're using here, because in this query, we have two tables present. And so it is not enough to simply write the name of columns. It is also necessary to specify to which table each column belongs. And we do it with this notation. So the inventory.character is saying that we are talking about the character ID column in the inventory table and the ID column in the characters table. So it's important to write columns with this notation in order to avoid ambiguity when you have more than one table in your query. So until now, we have used the from clause to specify where do we want to get data from. And normally this was simply specifying the name of a table. Here we are doing something very similar, except that we are creating a new table that is obtained by combining two pre-existing tables. Okay, so we are not getting our data from the characters table and we are not getting it from the inventory table, but we are getting it from a brand new table that we have created by combining these two. And this is where our data lives. And to complete the query for now, we can simply add a select star and you will now see the result of this query. So let me actually make some room here and expand these results so I can show you what we got. And as you can see here, we have a brand new table in our result. And you will notice if you check the columns that this table includes all of the columns from the characters table and also all of the columns from the inventory table, as you can see here. And they have been combined by our join statement. Now, to get a better sense of what's happening, let us get rid of this star and let us actually select the columns that we're interested in. And once again, I will write columns with this notation in order to avoid ambiguity. And in selecting these columns, I will remind you that we have all of the columns from the characters table and all of the columns from the inventory table to choose from. So what I will do here is that I will take the ID columns from characters and I will take the name column from characters. And then I will want to see the ID of the item. So I will take the inventory table and the item ID column from that table. And from the inventory table, I will also want to see the quantity of each item. And to make our results clearer, I will order my results by the character's ID and the item ID. And you can see here that we get the result that we needed. We have all of our characters here with their IDs and their name. And then for each character, we can tell which items are in their inventory. So you can see here that Aragorn has item ID 4 in his inventory in quantity of 2. He also has item 99. So because of this, Aragorn has 2 rows. If we look back at Frodo, we see the information that we retrieved before, and the same for Gandalf, who has these 2 items. So we have combined the characters table and the inventory table to get the information that we needed. What does each row represent in our result? Well, it's the same as the inventory table. Each row is a fact, which is that a certain character possesses a certain item. But unlike the inventory table, we now have all the information we want for a character and not just the ID. So here we're showing the name of each character, but we could of course select more columns and get more information for each character as needed. Now a short note on notation. When you see SQL code in the wild and a query is joining on 2 or more tables, people, programmers were usually quite lazy and we don't feel like writing the name of the table all of the time, right? Like we were doing in this case with characters. So what we usually do is that we add an alias on the table like this. So from fantasy characters, call it C, we will join on inventory, call it I, and then basically we use this alias everywhere in the query, both in the instructions for joining and in the column names, and the same with characters. So I will substitute everything here. And yes, maybe it's a bit less readable, but it's faster to write and we programmers are quite lazy, so you'll often see this notation. And you will often also see that in the code we omit the as keyword, which can be, let's say, implicit in SQL code. And so we write it like this: from fantasy.character C, join fantasy.inventory I, and then C and I refer to the 2 tables that we're joining. And I can run this and show you that the query works just as well. Now, we've seen why join is useful and how it looks like, but now I want you to get a detailed understanding of how exactly the logic of join works. And for this, I'm gonna go back to my spreadsheet, and what I have here is my characters table and my inventory table. These are just like you've seen them in BigQuery, except that I'm only taking 4 rows each in order to make it simpler for the example. And what you see here is the same query that I've just run on BigQuery. This is a query that takes the characters table, joins it on the inventory table on this particular condition. and then picks a few columns from this. So let us see how to simulate this query in Google Sheets. Now, the first thing I need to do is to build the table that I will run my query on. Because as we've said before, the from part is now referencing not the characters table, not the inventory table, but the new table, which is built by combining these two. And so our first job is to build this new table. And the first step to building this new table is to take all of the columns from characters and put them in the new table. And then take all of the columns from inventory and then put them in the new table. And what we've obtained here is the structure of our new table. The structure of our new table is simply created by taking all of the columns of the table on the left along with all of the columns from the table on the right. Now, I will go through each character in turn and consider the join condition. The join condition is that the ID of a character is present in the character ID column of inventory. So let us look at my first character. We have Aragorn and he has ID 1. Now, is this ID present in the character ID column? Yes, I see it here in the first row. So we have a match. Given that we have a match, I will take all of the data that I have in the characters table for Aragorn, and then I will take all of the data in the inventory table for the row that matches. And I have built here my first row. Do I have any other row in the inventory table that matches? Yes, the second row also has a character ID of 1. So because I have another match, I will repeat the operation. I will take all of the data that I have in the left table for Aragorn, and I will add all of the data from the right column in the row that matches. Now, there are no more matches for ID 1 in the inventory table, so I can proceed. And I will proceed with Legolas. He has character ID of 2. Question: is there any row that has the value 2 in the character ID column? Yes, I can see it here. So I have another match. So just like before, I will take the information for Legolas and paste it here. And then I will take the matching row, which is this one, and paste it here. We move on to Gimli because there's no other matches for Legolas. Now, Gimli has ID 3 and I can see a match over here. So I will take the row for Gimli, paste it here, and then take the matching row, character ID 3, and paste it here. Great. Finally, we come to Frodo, character ID 4. Is there any match for this character? I can actually find no match at all. So I do nothing. This row does not come into the resulting table because there is no match. And this completes the job of this part of the query over here, building the table that comes from joining these two tables. This is my resulting table. And now to complete the query, I simply have to pick the columns that the query asks for. So the first column is character.id, which is this column over here. So I will take it and I will put it in my result. The second column I want is character.name, which is this column over here. The third column is the item ID column, which is this one right here. And finally, I have quantity, which is this one right here. And this is the final result of my query. And of course, this is just like any other SQL table, so I can use all of the other things I've learned to run logic on this table. For example, I might only want to keep items that are present in a quantity of 2, and so to do that, I will simply add a where filter here, and I will refer the inventory table because that's the parent table of the quantity column. So I will say I.quantity bigger or equal to 2, and then how my query will work is that first it will build this table like we've seen, so it will do this stage first, and then it will run the where filter on this table, and it will only keep the rows where quantity is at least 2, and so as a result we will only get this row over here instead of this result that we see right here, except that we will of course also have to only keep the columns that are specified in the select statement. So we will get ID, name, item ID, and quantity. So this will be the result of my query after I've added a where filter. So let us actually take this and add it to BigQuery and make sure that it works. So I have to add that after the from part and before the order by part, right? This is the order. And after I run this, I will see that indeed I get Aragorn and Frodo. Is not exactly the same as in our sheet, but that's because our sheet has less data. But this is what we want to achieve. And now let us go back to our super important diagram of the order of SQL operation, and let us ask ourselves, where does the join fit in this schema? And as you can see, I have placed join at the very beginning of our flow together with the from, because the truth is that the join clause is not really separate from the from clause. They are actually one and the same component in the logical order of operations. So as you remember, the first stage specifies where our data lives, where do we want to get our data from. And until now, we were content to answer this question with a single table name, with the address of a single table, because all the data we needed was in just one table. And now, instead of doing this, we are taking it a step further. We are saying our data lives in a particular combination of 2 or more tables. So let me tell you which tables I want to combine and how I want to combine them. And the result of this will be, of course, yet another table. And then this table will be the beginning of my flow. And after that, I can apply all the other operations that I've come to know on my table, and it will work just like all our previous examples. The result of a join is, of course, just another table. So when you look at a SQL query and this query includes a join, you really have to see it as one and the same with the from part. It defines the source of your data by combining tables, and everything else that you do will be applied not to a single table, not to any of the tables that you're combining. Everything that you do will be applied to the resultant table that comes from this combination. And this is why from and join are really the same component, and this is why they are the first step in the logical order of SQL operations. Let us now briefly look at multiple joins, because sometimes the data that you need is in 3 tables or 4 tables, and you can actually join as many tables as you want, or at least as many tables as your system allows you to join before it becomes too slow. So we have our example here from before. We have each character and we have their name and we know which items are in their inventory. But we actually don't know what the items are. We just know their ID. So how can I know that if Aragorn has item 4, what item does Aragorn actually have? What is the name of this item? Now, obviously this information is available in the items table that you have here on the right, and you can see here that we have a name column. And just like before, I can actually eyeball it, I can look for it myself. I know that I'm looking for item ID 4, and if I go here and I go to 4, I can see that this item is a healing potion. And now let us see how we can add this with the join. So now I will go to my query, and after joining with characters and inventory, I will take that result and simply join it on a third table. So I will write join on fantasy.items, and I can call this IT to use a brief form because I am lazy, as all programmers are. And now I need to specify the condition on which to join. So the condition is that the item ID column, which actually came from the inventory table, right? That's its parent. So I'm going to call it inventory.item ID, except that, yeah, I'm referring to inventory as a simple I. That is the brief form, is the same as the items table, the ID column in the items table. And now that I've added my condition, the data that I'm searching is now a combination of these three tables. And in my result, I now have access to the columns of the items table. And I can access these columns simply by referring to them. So I will say it.name and some other thing, it.power. And after I run this query, I should be able for each item to see the name and the power, right? So Aragorn has a healing potion with power of 50, Legolas has a elven bow with power of 85, and so on. Now, you may have noticed something a bit curious, and it's that name here is actually written as name_1. And can you figure out why this is happening? Well, it's happening because there's an ambiguity, right? The characters table has a column called name, and the items table also has a column called name. And because BigQuery is not referring to the columns the way we are doing it, right, by saying the parent table and then the name of the column, it would find itself in a position of having two identically named columns. So the second one, it tries to distinguish it by adding _1. And how we can remedy this is by renaming the column to something more meaningful. For example, we could say call this item name, which would be a lot clearer for whoever looks at the result of our query. And as you can see, now the name makes more sense. So you can see that the multiple join is actually nothing new, because when we join the first time, like we did before, we have combined two tables into a new one. And then this new table gets joined to a third table. So it's simply repeating the join operation twice. It's nothing actually new. But let us actually simulate a multiple join in our spreadsheet to make sure that we understand it and that it's nothing new. So again, I have our tables here, but I have added the items table, which we will combine. And I've written here our query, right? So take the characters table and join it with inventory like we did before. And then take the result of that table and join it to items. And here we have the condition. So the first thing we need to do is to process our first join. And this is actually exactly what we've done before. So let us do it again. First of all, the combined table, characters and inventory, Its structure is obtained by taking all the columns of characters and then all the columns of inventory and putting them side by side. And this is the result table. Now for the logic of this table, I will now do it faster because we've done it before, but basically we get the first character ID1, it has 2 matches, so I'll actually take these values and put them into 2 rows, and for the inventory part, I will simply copy these 2 rows to complete my match. Then we have Legolas. There is 1 match here, so I will take the left side and I will take, so I'm looking for ID2, so I will take this row over here. That's all we have. And then we have Gimli, and he also has 1 match, so I'll take it here and the resulting column. And then finally, Frodo has no match, so I will not add him to my result. This is exactly what we've done before. So now that we have this new table, we can proceed with our next join, which is with items. Okay, so the resulting table will be the result of our first join combined with items. And to show you that we've already computed this, and now it's one table, I have added round brackets. Now the rules for joining are just the same. So take all of the columns in the left side table and then take all of the columns in the right side table, and now we have the resulting structure of our table. And then let us go through every row. So let us look at the first row. What does the join condition say? Item ID needs to be in the ID table of items. So I can see a match here. So I will simply take this row on the left side and the matching row on the right side and add it here. Second row, the item ID is 4. Do I have a match? Yes, I can see that I have a match. So I will paste the row on the left and the matching row on the right. Third column, item ID 2. Do I have a match? No, I don't. So I don't need to do anything. And in the final row, item ID 101, I don't see a match, so I don't have to do anything. And so this is my final result. In short, multiple join works just like a normal join. Combine the first 2 tables, get the resulting table, and then keep doing this until you run out of joins. Now, there's another special case of join, which is the self-join. And this is something that people who are getting started with SQL tend to find confusing, but I want to show you that there's nothing confusing about it, because really it's just a regular join that works just like all the other joins that we've seen. There's nothing actually special about it. So we can see here the characters table. And you might remember that for each character, we have a column of mentor ID. Now, in a lot of cases, this column has value null, so it means that there's nothing there. But in some cases, there is a value there. And what this means is that this particular character, so we are looking at number 3, that is Saruman, this particular character has a mentor. And who is this mentor? All we know is that their ID is 6. And it turns out that the ID in this column is referring to the ID in the characters table. So to find out who 6 is, I just have to look who has an ID of 6, and I can see that it is Gandalf. So by eyeballing it, I know that Saruman has a mentor, and that mentor is Gandalf. And then Elrond also has the same mentor, which is Gandalf. So I can solve this by eyeballing the table, but how can I get a table that shows for each character who has a mentor who their mentor is? It turns out that I have to take the characters table and join it on the characters table, on itself. So let's see how that works in practice. So let me start a new query here on the right. And so my goal here is to list every character in the table and then to also show their mentor if they have one. So I will of course have to get the characters table for this, and the first time I take this table, it is simply to list all of the characters, right? So to remind myself of that, I can give it a label which is chars. Now, as you know, each character has a mentor ID value, but to find out what is the name of this mentor, I actually need to look it up in the characters table. So to do this, I will join on another instance of the characters table, right? This is another, let's say, copy of the same data, but now I'm going to use it for a different purpose. I will not use it to list my characters. I will use it to get the name of the mentor. So I will call this mentors to reflect this use. Now, what is the logical connection between these two copies of the characters table? Each character in my list of characters has a mentor ID field, and I want to match this on the ID field of my mentors table. So this is the logical connection that I'm looking for. And I can now add a select star to quickly complete my query and see the results over here. So the resulting table has all of the columns of the left table and all of the columns of the right table, which means that the columns of the characters table will be repeated twice in the result, as you can see here. But on the left, I simply have my list of characters. Okay, so the first one is Saruman. And then on the right, I have the data about their mentor. So Saruman has a mentor ID of 6, and then here starts the data about the mentor. He has ID of 6, and his name is Gandalf. So you can see here that our self-join has worked as intended. But this is actually a bit messy. We don't need all of these columns. So let us now select only the columns that we need. So from my list of characters, I want the name. And then from the corresponding mentor, I also want the name. And I will label these columns so that they make sense to whoever is looking at my data. So I will call this character name, and I will call this mentor name. And when I run this query, you can see that quite simply we get what we wanted. We have the list of all our characters, at least the ones who have a mentor. And for each character, we can see the name of their mentor. So a self-join works just like any other join, and the key to avoiding confusion is to realize that you are joining on two different copies of the same data, okay? You're not actually joining on the same exact table. So one copy of fantasy characters we call characters and we use for a purpose, and then a second copy we call mentors and we use for another purpose. And when you realize this, you see that you are simply joining two tables and all the rules that you've learned about normal joins apply. It just so happens that in this case, the two tables are identical because you're getting the data from the same source. And to drive the point home, let us quickly simulate this in our trusty spreadsheet. And so as you can see here, I have the query that I've run in BigQuery, and we're now going to simulate it. So the important thing to see here is that we're not actually joining one table to itself, although that's what it looks like. We're actually joining two tables which just happen to look the same, okay? And so one is called chars and one is called mentors based on the label that we've given them. But then once we join them, the rules are just the same as we've seen until now. So to create the structure of the resulting table, take all the columns from the left, and then take all the columns from the right. And then go row by row and look for matches based on the condition. Now, the condition is that mentor ID in chars needs to be in the ID column of mentors. So first row, Aragorn has mentor 2. Is this in the ID column? Yes, I can see a match here. So let me take all the values from here and all the values from the matching rows, paste them together. Are there any other matches? No. Second row, we're looking for mentor ID 4. Do we have a match? Yes, I can see it here. So let me take all of the values from the left and all of the values from the matching row on the right. Now we have 2 more rows, but as you can see, in both cases, mentor ID is null, which means that they have no mentor. And basically, for the purposes of the join, we can ignore these rows. We are not going to find a match in these rows. In fact, as an aside, even if there was a character whose ID was null, we wouldn't match with mentor ID null on a character whose ID was null, because in SQL, in a sense, null does not equal null, because null is not a specific value, but it represents the absence of data. So in short, when mentor ID is null, we can be sure that in this case, there will be no match and the row will not appear in the join. Now that we have our result, we simply need to select the columns that we want. And so the first one is name, which comes from the chars table, which is this one over here. And the second one is name that comes from the mentors table, which is this one over here. And here is our result. So that's how a self-join works. So until now, we have seen join conditions which are pretty strict and straightforward, right? So there's a column in the left table and there's a column in the right table and they represent the same thing. And then you look for an exact match between those 2 columns, and typically they're an ID number, right? So one table has the item ID, the other table also has the item ID, and then you look for an exact match, and if there's an exact match, you include the row in the join, otherwise not. That's pretty straightforward, but what I want to show you here is that the join is actually much more flexible and powerful than that. And you don't always need 2 columns that represent the exact same thing or an exact match in order to write a joining condition. In fact, you can create your own, complex conditions and combinations that decide how to join 2 tables. And for this, you can simply use the Boolean algebra magic that we've learned about in this course and that we've been using, for example, when working on the where filter. So let us see how this works in practice. Now, I've tried to come up with an example that will illustrate this. So let's say that we have a game, a board game or video game or whatever, and we have our characters and we have our items, okay? And in our game, a character cannot simply use all of the items in the world, okay? There is a limit to which items a character can use. And the limit is based on the following rule. Let me write it here as a comment and then we will use it in our logic. So a character can use any item for which the power level is equal or greater than the character's experience divided by 100. Okay, so this is just a rule that exists in our game. And now let us say that we wanted to get a list of all characters and the items that they can use. Okay, and this is clearly a case where we would need a join. So let us actually write this query. I will start by getting my data from fantasy.characters, and I will call this C as a shorthand. and I will need to join on the items table, right? And what is the condition of the join? The condition of the join is that the character's experience divided by 100 is greater or equal than the item's power level. And I forgot here to add a shorthand I for the items table. So this is the condition that reflects our rule. And out of this table that I've created, I would like to see the character's name and the character's experience divided by 100. And then I would like to see the item's name and the item's power to make sure that my join is working as intended. So let us run this and look at the result. So this looks a bit weird because we haven't given a label to this column, but basically I can see that I have Gandalf and his experience divided by 100 is 100, and he can wear the item Excalibur that has a power of 100, which satisfies our condition. Let me actually order by character name so that I can see in one place all of the items that a character can wear. So we can see that Aragorn is first and his experience divided by 100 is 90, and then this is the same in all of these rows that we see right now. But then we see all of the items that Aragorn is allowed to use, and we see their power. And in each case, you will see that their power does not exceed this value on the left. So the condition that we wrote works as intended. So as you can see, what we have here is a Boolean expression, just like the ones we've seen before, which is a logical statement that eventually, if you run it, it evaluates to either true or false. And all of the rules that we've seen for Boolean expressions apply here as well. For example, I can decide that this rule over here does not apply to mages because mages are special. And then I can say that if a character is mage, then I want them to be able to use all of the items. Well, how can I do this in this query? Can you pause the video and figure it out? So what I can do is to simply expand my Boolean expression by adding an OR, right? And what I want to test for is that character class equals mage. So let me check for a second that I have class and I have mage, so this should work. And if I run this, going through the result, I will not do it, but you can do it yourself and verify for yourself that if a character is a mage, you will find out that they can use all of the items. And this, of course, is just a Boolean expression in which you have two statements connected by an OR. So if any of these is true, if at least one of these two is true, then the whole statement will evaluate to true, and so the row will match. If you have trouble seeing this, then go back to the video on the Boolean algebra, and everything is explained in there. So this is just what we did before when we simulated the join in the spreadsheet. You can imagine taking the left side table, which is characters, and then going row by row. And then for the first row, you check all of the rows in the right side table, which is items, all of the rows that have a match. But this time, you won't check if the ID corresponds. You will actually run this expression to see whether there is a match, and when this expression evaluates as true, you consider that to be a match and you include the row in the join. However, if this condition does not evaluate to true, it's not a match, and so the row is not included in the join. So this is simply a generalization from the exact match. which shows you that you can use any conditions in order to join two tables. Now, I've been pretending that there is only one type of join in SQL, but that is actually not true. There are a few different types of join that we need to know. So let us see what they are and how they work. Now, this is the query that we wrote before, and this is exactly how we've written it before. And as you can see, we've simply specified join. But it turns out that what we were doing all the time was something called inner join, okay? And now that I've written it explicitly, you can see that if I rerun the query, I will get exactly the same results. And this is because the inner join is by far the most common type of join that you find in SQL. And so in many styles of SQL, such as the one used by BigQuery, they allow you to skip this specification and they allow you to simply write join, and then it is considered as an inner join. So when you want to do an inner join, you have the choice whether to specify it explicitly or to simply write join. But what I want to show you now is another type of join called left join, okay? And to see how that works, I want to show you how we can simulate this query in the spreadsheet. So as you can see, this is very similar to what we've done before. I have the query that I want to simulate, and notice the left join, and then I have my two tables. Now, what is the purpose of the left join? In the previous examples, which were featuring the inner join, we've seen that when we combine two tables with an inner join, the resulting table will only have rows that have a match in both tables, okay? So what we did is that we went through every row in the characters table, and if it had a match in the inventory table, we kept that row. But if there was no match, we completely discarded that row. But what if we wanted, in our resulting table, to see all of the characters, to make sure that our list of characters was complete, regardless of whether they had a match in the inventory table? This is what left join is for. Left join exists so that we can keep all of the rows in the left table, whether they have a match or not. So let us see that in practice, okay? So we need to do a left join between characters and inventory. So first of all, I need to determine the structure of the resulting table. And to do this, I will take all of the columns from the left table and all of the columns from the right table. Nothing new there. Next step, let us go row by row in the left table and look for matches. So we have Aragorn, and he actually has two matches. By now we've remembered this, so these two rows have a match in character ID with the ID of characters. So I will take these two rows and add them to my resulting table. Next is Legolas, and I see a match here. So I will take the rows where Legolas matches and put it here. It's only one row actually. Gimli has also a single match, so I will create the row over here. And so this is the match for Gimli. And of course I can ensure that I'm doing things correctly by looking at this ID column and this character ID column over here, and they have to be identical, right? If they're not, then I've made a mistake. And finally, we come to Frodo. Now, Frodo, you will see, does not have a match in this table. So before, we basically discarded this row because it had no match. Right now, though, we are dealing with a left join. That means that all of the rows in the characters table need to be included. So I don't have a choice. I need to take this row and include it and add it here. And now the question is, what values will I put in here? Well, I cannot put any value from the inventory table because I don't have a match. So the only thing that I can do is to put nulls in here. Nulls, of course, represent the absence of data, so they're perfect for this use case. And that basically completes the sourcing part of our left join. Now, you may have noticed that there is an extra row here in inventory which does not have a match, right? It is referring to character ID 10, but there is no character ID 10. So here, the Frodo row also did not have a match, but we included it. So should we include this row as well? The answer is no. Why not? Because this is a left join, okay? So left join means that we include all of the rows in the left table, even if they don't have a match. But we do not include rows in the right table when they do not have a match, okay? This is why it's a left join. So, but if you're still confused about this, don't worry because it will become clearer once we see the other types of join. And of course, for the sake of completeness, I can actually finish the query by selecting my columns, which would be the character ID and the character name and the item ID and the item quantity. And this is my final result. And in the case of Frodo, we have null values, which tells us that this row found no match in the right table, which in this case means that Frodo does not have any items. Now that you understand the left join, you can also easily understand the right join. It is simply the symmetrical operation to the left join, right? So whether you do characters, left join inventory, or you do inventory right join characters, the result will be identical. It's just a symmetrical operation, right? This is why I wrote here that table A left join B equals table B right join A. So hopefully that's pretty intuitive. But of course, if I did characters right join inventory, then the results would be reversed because I would have to keep all of the rows of inventory regardless of whether they have a match or not, and only keep rows in characters which have a match. So if you experiment for yourself on the data, you will easily convince yourself of this result. Let us now see the left join in practice. So remember the query from before where we take each character and then we see their mentor. This is the code exactly as we've written it before. And so now you know that this is an inner join, because when you don't specify what type of join you want, SQL assumes it's an inner join. At least that's what the SQL in BigQuery does. And you can see that if I write inner join, I think I have a typo there. The result is absolutely identical. And in this case, we're only including characters who have a mentor, right? We are missing out on characters who don't have a mentor, meaning that mentor ID is null, because in the inner join, there is no match, and so they are discarded. But what would happen if I went here and instead turned this into a left join? What I expect to happen is that I will keep all of my characters, so all of the rows from the left side table, regardless of whether they have a match or not, regardless of whether they have a mentor or not. And so let us run this and let us see that this is in fact the case. I now have a row for each of my characters, and I have a row for Gandalf, even though Gandalf does not have a mentor, and so I have a null value in here. So the left join allows me to keep all of the rows of the left table. Now, we've seen the inner join, the left join, and the right join, which are really the same thing, just symmetrical to each other. And finally, I want to show you the full outer join. This is the last type of join that I want to show you. Now you will see that a full outer join is like a combination of all of the joins that we've seen until now. So a full outer join gives us all of the rows that have a match in the two tables, plus all of the rows in the left table that don't have a match with the right table, plus all of the rows in the right table that don't have a match in the left table. So let us see how that works in practice. What I have here is our usual query, but now, as you can see, I have specified a full outer join. So let us now simulate this join between the two tables. Now the first step, as usual, is to take all of the columns from the left table and all of the columns from the right table to get the structure of the resulting table. And now I will go row by row in the left table. So as usual, we have Aragorn, and you know what? I'm already going to copy it here because even if there's not a match, I still have to keep this row because this is a full outer join and I'm basically not discarding any row. Now that I've copied it, is there a match? Well, I already know from the previous examples that there are two rows in the inventory table that match because they have character ID 1. So I'm just gonna take them and copy them over here. And in the second row, I will need to replicate these values. Perfect. Let me move on to Legolas. And again, I can already paste it because there's no way that I'm going to discard this row. But of course we know that Legolas has a match. And moving quickly, because we've already seen this, Gimli has a match as well. And now we come to Frodo. Now, Frodo, again, I can already copy it because I'm keeping all the rows. But Frodo does not have a match. So just like before with the left join, I'm going to keep this row, but I'm going to add null values in the columns that come from the inventory table. So now I've been through all of the rows in the left table, but I'm not done yet with my join, because in a full outer join, I have to also include all of the rows from the right table. So now the question is, are there any rows in the inventory table that I have not considered yet? And for this, I can check the inventory ID from my result, 1, 2, 3, 4, and compare it with the ID from my table, 1, 2, 3, 4, 5, and then I realize that I have not included row number 5 because it was not selected by any match. But since this is a full outer join, I will add this row over here, I will copy it, and of course it has no correspondent in the left table, so what do? Once again, I will insert null values. And that completes the first phase of my full outer join. The last phase is always the same, right? Pick the columns that are listed in the select. So you have the ID, the name, item ID, and quantity. And this completes my full outer join. So remember how I said that a full outer join is like an inner join plus a left join plus a right join? Here is a visualization that demonstrates. Now, in the result, the green rows are the rows in which you have a match on the left table and the right table, right? And these rows correspond to the inner join. And if you run an inner join, this will be the only rows that are returned, right? Now, the purple row is including a row that is present in the left table, but does not have any match in the right table. So If you were to run a left join, what would the result be? A left join would include all of the green rows because they have a match. And additionally, they would also include the purple row because in the left join, you keep all of the rows from the left. If, on the other hand, you were to run a right join and you wouldn't like swap the names of the tables or anything, right? You would do characters, right join, inventory. You would get, of course, all of the green rows because they are a match. Additionally, you would get the blue row at the end because this row is present in the right table, even though there's no match. And in the right join, we want to keep all the rows that are in the right table. And finally, in a full outer join, you will include all of these rows, right? So first of all of the rows that have a match, and then all of the rows in the left table, even though they don't have a match, and finally all of the rows in the right table, even though they don't have a match. And these are the 3 or 4 types of join that you need to know and that you will find useful in solving your problems. Now, here's yet another way to think about joins in SQL and to visualize joins, which you might find helpful. So one way to think about SQL tables is that a table is a set of rows and that joins correspond to different ways of combining sets. And you might remember this from school. This is a Venn diagram. It represents the relation between two sets and the elements that are inside these two sets. So you can take set A to be our left table, containing all of the rows from the left table, and set B to be our right table with all of the rows from the right table. And in the middle here, you can see that there is an intersection between the sets. This intersection represents the rows that have a match. So these would be the rows that I have colored green in our example over here. So what will happen if I want to see only the rows that are a match, only the rows that belong in both tables? Let me select this now, and you can see that this corresponds to an inner join, because I only want to get the rows that have a match. Then what would happen if I wanted to include all of the rows in the left table, regardless of whether they have a match or not? To what type of join does that correspond? I will select it here, and you can see that that corresponds to a left join. The left join produces a complete set of records from table A with the matching records in table B. If there is no match, the right side will contain null. Likewise, if I wanted to keep all of the rows in table B, including the ones that match with A, I would of course get a right join, which is just symmetrical to a left join. Finally, what would I have to do to include all of the rows from both tables, regardless of whether they have a match or not? If I do this, then I will get a full outer join. So this is just one way to visualize what we've already seen. There is one more thing you can actually realize from this tool, which is in some cases, you might want to get all of the records that are in A, except those that match in B. So all of the records that A does not have in common with B. And you can see how you can actually do this. This is actually a left join with an added filter where the B key is null. So what does that mean? The meaning will be clear if I go back to our example for the left join. You can see that this is our result for the left join. And because Frodo had no match in the right table, the ID column over here is null. So if I take this table and I apply a filter where where inventory ID is null, I will only get this result over here, and this is exactly the one row in the left table that does not have a match in the right table. So this is more of a special case. You don't actually see this a lot in practice, but I wanted to show it briefly to you in case you try it and get curious about it. Likewise, the last thing that you can do, you could get all of the rows from A and B that do not have a match. So the set of records unique to table A and table B, and this is actually very similar. You do a full outer join and you check that either key is null. So either inventory ID is null or character ID is null. And if you apply that filter, you will get these two rows, which is the set of rows that are in A and only in A, plus the rows that are in B and only in B. Once again, I've honestly never used this in practice. I'm just telling you for the sake of completeness in case you get curious about it. Now, a brief but very important note on how SQL organizes data. So you might remember from the start of the course that I've told you that in a way, SQL tables are quite similar to spreadsheet tables, but there are two fundamental differences. One difference is that each SQL table has a fixed schema, meaning we always know what the columns are and what type of data they contain. And we've seen how this works extensively. The second thing was that SQL tables are actually connected with each other, which makes SQL very powerful. And now we are finally in a position to understand just exactly how SQL tables can be connected with each other. And this will allow you to understand how SQL represents data. So I came here to dbdiagram.io, which is a very nice website for building representations of SQL data. And this is this type of chart of representation that we see here is also known as ERD, as you can see me writing here, which is stands for Entity Relationship Diagram. And it's basically a diagram that shows you how your data is organized in your SQL system. And so you can see a representation of each table. This is the example that's shown on the website. And so you have three tables here: users, follows, and posts. And then for each table, you can see the schema, right? You can see that the users table has 4 columns. One is the user ID, which is an integer. The other is the username, which is varchar. This is another way of saying string. So this is a piece of text. Role is also a piece of text. And then you have a timestamp that shows when the user was created. And the important thing to notice here is that these tables are actually, they don't exist in isolation, but they are connected with each other. They are connected through these arrows that you see here. And what do these arrows represent? Well, let's look at the follows table, okay? So each row of this table is a fact, shows that one user follows another. And so in each row you see the ID of the user who follows and the ID of the user who is followed, as well as the time when this event happened. And what are these arrows telling us? They're telling us that the IDs in this table are the same thing as the user ID column in this table, which means that you can join the follows table with the users table to get the information about the two users that are here, the user who is following and the user who is followed. So, like we've seen before, a table has a column which is the same thing as another table's column, which means that you can join them to combine their data. And this is how in SQL several tables are connected with each other. They are connected by logical correspondences that allow you to join those tables and combine their data. Likewise, you have the posts table, and each row represents a post, and each post has a user ID. And what this arrow is telling you is that you can join on the user table using this ID to get all the information you need about the user who has created this post. Now, of course, as we have seen, you are not limited to joining the tables along these lines. You can actually join these tables on whatever condition you can think of. But this is a guarantee of consistency between these tables that comes from how the data was distributed. And it's a guarantee, it's a promise that you can get the data you need by joining on these specific columns. And that is really all you need to know in order to get started with joins and use them to explore your data and solve SQL problems. To conclude this section, I want to go back to our diagram and to remind you that from and join are really one and the same. They are the way for you to get the data that you need in order to answer your question. And so when the data is in one table alone, you can get away with just using the from and then specifying the name of the table. But often your data will be distributed in many different tables. So you can look at the ERD diagram, such as this one, if you have it, to figure out how your data works. And then once you decided which tables you want to combine, you can write a from which combines with a join, and so create a new table which is a combination of two or more tables, and then all of the other operations that you've learned will run on top of that table.